In today's session, you are going to learn what is all about production analysis, what is the ISO, what is the returns to factor, returns to scale in detail. So let's begin. What is exactly production is? Production is a process that how to use the combination of the various inputs or the combination of the various factors inputs in order to produce the goods and services in a market. That's called production. Production, in other words, production is also a process that how to transform input into outputs, and that also calls production. What are inputs? Input refers to all those factors of productions to use in the production process. So once the inputs would get processed, get transformed into the output. So output is a final product. So output is, you can say, in other words, it is called a finished product. That how by using the various you can say factor inputs and process in a very organized manner to get some output, and that output is called the final product and finished product, which is, we can see it, we get at the end of the production process. That's called the final product or finished goods, and that's called output. Now to talk about the classifications of factors in you can say production or the factor inputs, in other words, the land, labor, capital, and entrepreneur or organization or enterprise. So when we talk about land, what is land? So always it all includes all the natural resources or a gift of nature. That's called land. It would be you can say the tree, any kind of you can say the natural resources, the natural activities to be done, to be naturally done. That's called land. So when you talk about labor, labor is refers to a physical or mental activities of the human beings. That how the particular person or willpower would be physically strong or mentally strong when it's related to all those activities of the physical or mental of human beings. So when we talk about capital, capital is a man-made, you can say, material which is used for further production. So every production needs money, every production needs funds, and that funds comes from the capital of the organization. And capital is generated by the credit as well as the own asset facilities, so that accordingly that can be used up for further production. The next one is entrepreneur or enterprise or organization. So any person which combines, or you can say, the different factors of productions and initiates work in the particular process of production, and then it calls the factors, and it also includes the factors of risk, and that's called entrepreneur. So entrepreneur is a person who not only combine the various factors of production, not only process or turn into the final product, it also includes or also take a courage. What they have is or in other words, we can say a risk taker. You also could take a risk of all those process of production which have a challenging and a courage to take upon it, and that person is called entrepreneur. The next one is production function. So what is production function is? Production function is a very formal or a functional relationship between the inputs and output, where it shows a maximum output or a same level of output could be produced by combining all those factors which are needed to get the final or finished product. and that's called the production function. So, in other words, production function is also a statement, a formal statement, which shows a functional relationship between inputs and output, where to reach out the maximum output by combining the various inputs like capital, land, labor, machinery, technology, etc. So when we talk about you can see Q stands for level of production or output and is a function of all those inputs which is used for further process of production. So land E stands for capital, L stands for labor, M stands for raw material, machinery, we can say enterprise. That's called the production function. Technology, we could say that is the function of output. So when we talk about the types of factor input, there are two main types. That is the fixed input and variable input. So when we talk about fixed input, the quantity where it is an input where quantity does not change according to the amount of output. For example, machinery, the quantities of machinery couldn't be changed. Even it you can say that it produces the same level of output. Land, it couldn't be changed. It always been fixed input. Buildings always being fixed. Tools also being fixed. Equipments is also being fixed. And that's called the fixed inputs. That quantity will remains constant according to the amount of output. So in other words, I could say if the output you can see changes, but the quantity will remains constant. Variable input, an input where the quantity changes according to the amount of output. So it means if there is a change in the quantity, automatically it will change in the output, and that's called the variable input. So if the one if the fact if the inputs are constant, even if there is change in output at the increase or decrease, that is fixed. Variable, there is a change in quantity due to the change in the amount of output. That's called the variable input. For example, raw material, electricity, transportation facilities, fuel, communication facilities, internet facilities, etc. They're all variable inputs. Even when we talk about the process of production and during the production functioning, the both inputs are equally important, fixed and variable. And without these inputs, production process would become incomplete. When we talk about the production function, there are two type of periods, which is very important to understand before we reach to the law of variable proportion, law of returns to scale. So it is in period is always been important in such particular topics. So when we talk about the shortened period, it's a time frame we can talk about where at least one of the factors inputs, that is the factors of production, is fixed and other means other inputs could be varied. That means could be changed. That's called the shortened period. So shortened period where one input would become fixed and other inputs would get changed, and that's called the short-run period. But when we talk about long-run period, is a fine frame where all the inputs are variable, or where the quantity changes as the amount of output would get changed, and that's called the long run. So if we talk about during the long run, the variable inputs are more equivalent, but during the short run, the fixed inputs are more equivalent. So these are the two main periods, that is short-run period and the long-run period. So when we talk about short-run period, or within that particular time frame, law of variable proportion will be followed. But when we talk about the, or you can say law of factors of productions. But when we talk about the long-run period, it's such a time frame where the returns to scale that is long run returns to scale, will be applied in such particular time frame. So this is the two main periods. So when we talk about the short run production function, so in the short run, as is indicated that one input will become fixed and the other input would become variable. That means it would get changed. So the one factor which is very important would get fixed is capital. So capital is one of the factor input would always be fixed depend on the amount of output or how much the firm would get the level of output or that yields some level of output. So in the short run, the production function will be written as follows. That is, the production is equal to function of K stands for capital and L stands for labor. That means Q is equal to function of capital and labor in short run, where in the short run, capital would remains fixed. So this is called the short run production function. So in the short run, we assume that one of the inputs would get fixed and the capital would and the cap that factor input which is capital will remains fixed only in the short-run production function. Now the most important concept is the law of variable proportion. In other words, it is called the law of diminishing marginal returns. So the law states that the quantities of certain factors would get increased while the quantities of one more factors would get constant beyond a certain level of production. It means the rate of output or amount of output will decrease. That means the rate of increase output would get increased but at a diminishing rate. So if any output increase at a diminishing rate, it's called law of diminishing marginal returns, which also such law also states that a few factors would get increased and the few one or more factors would get constant beyond some level of production or output. As a result, the rate or the amount of output will definitely increase but at a diminishing rate or at a decreasing rate, and such law is called diminishing marginal returns. And that is this concept is also it's also seen the or in other words it is also called the law of variable proportion. In other words, the law of diminishing marginal return states that as more and more variable input is used while keeping the other inputs or technology as one of the other inputs are fixed, the marginal product will immediately declines. Uh, when it says when the marginal product will become zero, total product, that means the total output, will become declines. And once the total product will declines at an increasing rate, immediately the marginal product will becomes negative. So this is called the law of diminishing margin. Here we are talking about not only about total output, total product. We also talk about the marginal product because the marginal product will be calculated from the total product itself or total output. That's why the law of diminishing marginal returns also relate to the marginal product. As more and more variable inputs will be used, the other inputs like technology and other technology organizations or will remains constant. In that case, the marginal product of the variable input will eventually or will immediately decrease or decline. So this is the law of diminishing marginal returns. When whatever the law states, The particular concepts will be followed accordingly. It cannot be changed in any way. So the law states that quantities of few factors inputs will constant and other factors inputs will remain variable beyond a certain level of output. As a result, the level of output will get increased but at a decreasing or diminishing rate. Or in other words, you can use this definition as more related to the marginal product, whereas more and more variable inputs will be used while the other inputs will remain constant. The marginal product of such variable input will immediately decline. So that's called the law of diminishing marginal return. So what the law states, it has to be followed accordingly. So there are three main concepts of production function, or you can say, uh, or under process of production, that is the total product, average product, and marginal product. So when we talk about total product, it is the total amount of output which is produced with a given level of inputs that is used with fixed inputs. As I already told, that fixed inputs is not always fixed. It is in the short run it becomes fixed, but in the long run it always the used with the variable with fixed inputs, and that's called total product. So total product is that amount of output produced when all given inputs is used along with the fixed inputs. So here is a combination of the variable and the fixed inputs, and that stands for total product. When we talk about average product refers to the total product divided by the number of inputs or number of units used in the production, and that's called average product. So the formula which has been given over here, that is total product and total labor, that is the number of units of input, that is total labor. In other words, TP by L, and that's called average product. So in other words, average product refers a division or a ratio of total product of, you can say, total labor. That's called average product. So when we talk about the marginal product is a change, it refers to a change in total product of that input corresponding to additional unit change in the labor, assuming all other factors will be constant. So marginal product refers to a total product by adding up an additional units into a one input, that is labor, assuming that all other inputs would remain constant or fixed, and that's called marginal product. Marginal product refers to a change in total product by change in total labor. So labor is one of the, you can say, the major variable input, or you can say factors of production in the short run, which is variable, and the fixed would remain capital. So that's why when we talk about the three types of products or three outputs, that is total product, average product, or marginal product, or marginal output, or average output, or total output, always labor one of the factor input which is used in the production process. But in case of total product, variable and the fixed inputs will be used. So marginal product is calculated by the change in total product by change in total labor, that is delta TP by delta L. So delta is the changes in total product and the changes in total labor. So this is the tabular representation, and in another diagram is a graphical representation. It is called the law of variable proportion, or it is called the law of you can say marginal diminishing returns, or diminishing marginal returns. So this is in the tabular representation, it is shown in the stages: stage 1, stage 2, stage 3. So if we talk about in the diagrammatic representation also, it is mentioned stage 1, stage 2, stage 3. So let's talk about the tabular representation. So when we talk about tabular representation, a capital that is a fixed input always being the short run, and the labor is a variable input will always be changes or increases according to the period of time. So the labor has been 0 to 10. It's increasing by a ratio of 1. Total product is given, that is 0, 8, 20, 33, 30, 44, 50, 54, 56, again 56, 54, 50, 50. So if you see the values of the total product, so it always portray that total product increases at an increasing rate and reaches to that level of output where the total product will remains constant. If you check out on the screen, the constant the total product will become constant on 56 units, that is 56 in and 56. So this is these two values where the total product will remains constant and then starts falling. So when we talk about TP increases as an increasing rate. It is stage 1. It reaches to a point which remains constant, that is on stage 2. When start falling, that is it reaches to increasing, then constant, then start declining. So that's called stage third. So once it increases at an increasing rate, it's stage 1, then constant stage 2, then start declining in stage 3. So this is the graphical representation you can see on the screen. That is stage 1, that is TP. We talk about the total product. Total product increases at an increasing rate, that is stage 1. Then it becomes constant, that is stage 2. Then it start declining, that is stage 3. When we talk about total product curve, that is shown over here in the blue line. When we talk about the purple curve, that is average product. When we talk about the light blue curve, we talk about the marginal product. So when we talk about the marginal product, so as why the marginal product has been given after the total product, because marginal product will be calculated on the basis of the total product, and average product will also be calculated on the basis of total product by dividing the number of units, that is labor. So marginal product, how to calculate the marginal product of the total product is just delta TP by delta L. So let's begin. Total marginal product. How to calculate the marginal product? Total product is already given. So the first input, that the unit input, that is 0. So marginal product will become 0. When we talk about the first unit of labor, the total product is 8. So 8 minus 0, it becomes 8 by change of labor. That is what is the formula of marginal product, that is change in total product. What is the change in total product? 8 minus 0, it's 8. Change in total labor, that is 1 minus 0, it's 1. So once you divide 8 by 1, you will get the marginal product 8. So let's talk about the second unit of labor. The total product is 20. So marginal product, how to calculate marginal product? The division, that is 20 minus 8, that is 12. Change in labor, 2 minus 1, that is 1. So once you divide 12 by 1, you will get the marginal product, it's 12. Let's talk about the third unit of labor. It's 33. So 33 minus 20 is 13. That is change in total product. By changing labor is 1. So 13 minus 1, the marginal product is 13. Same in case of fourth unit, 44 minus 33, that is 11. 11 by change in labor, how much? It is 1. So 11 by 1, we will get the marginal product 11. Same in case of fifth unit of labor, that is 50. 50 minus 44, it becomes 6. Changing labor, that is 1. So 6 by 1, we get the answer 6. 54 minus 54, changing labor is 1. 4 by 1, you will get the marginal product 4. Same in case of 56. 56 minus 56 becomes 0. Automatically, when any division will be divisible by 0, you will get 0. For 54 minus 56 minus 2, that is the difference of total product of initial unit and the last unit. That is 54 minus 56 minus 2 by difference of labor, that is 1. So minus 2 by 1, you will get the minus 2. 50 minus 54, that is minus 4 by 1, that is a change of labor is 1. So we will get minus 4. So these are the values has been estimated using the concept of total product and labor. So you will get the marginal product. So 0, 8, 12, 13, 11, 4, 2, 0, minus 2, minus 4. If you see the light brown, light blue curve, that is called the marginal product. Just slowly, the marginal product is increasing, then it start declining. If you see on the values, so I'll repeat once again, the marginal product initially it's increasing slowly and then declining frequently and reaches to zero level of output, and thereafter it becomes negative. That's a call or that's a shape of marginal product. I repeat once again, marginal product initially increases very slowly and decreases frequently and becomes zero, and then later it becomes negative. That's called marginal product, and that's called a shape of the marginal product, which is shown in the diagrammatic presentation. It increases very slowly, then decreases frequently and reaches to zero and becomes negative. So one more thing I would like to portray over here, that marginal product is calculated from the total product by having differences between the total product and by difference of labor. But when we talk about the marginal product, also the average product, not marginal, average product is also being calculated from the total product by dividing the number of labor units. That is 0, it's 0. 8 by 1, 8. 12 by 2, it's written average product. That is its division, that is average product, total product divided by number of labor, that is 8 by 1, 8. 20 by 2, 10. 22 by 3, 11. 44 by 4, 11. 50 by 5, 10. 54 by 6, 9. 56 by 7, 8. 56 by 8, 7. 54 by 9, 6. 50 by 10, 5. So these are the values has been calculated from the average, from the total product, that is average product. So average product has been shown over here. So that is how to show up the average product. It increases at a very initial stages. It increases at a very big, a very initial difference in the values of average product. It increases not at an increasing rate frequently, then decreases immediately very slowly by a ratio of one difference, and then become negative, then become declining. But as compared to total product and marginal product, average product is the most frequent to output, where it increases very initially, slowly, and then it becomes decline on a very uh, slowly declining the average product, and never touches the zero or becomes negative. It declining very initially or very slowly after the increasing level of average product, and that's called the shapes of from the tabular representation of average product, marginal product, and total product, and that's called the stages of production: stage 1, stage 2, stage 3. So if we talk of where at that point where the average product and total product. So if we look out the average product, which is it's increasing very slowly, and the marginal product is also increases very slowly. Where these two curves intersect each other, it means average product is equal to marginal product. So this where these 2 points, where two curves intersect each other at an increasing level, that point is called average product is equal to marginal product. So that's called a mean difference of average product and marginal product. So stages where the TP increases at an increasing rate, marginal and average product increases initially or slowly and intersect each other. That line is called stage 1. When the total product is constant, average product is declining, and marginal product is declining at a very and reaches to zero at stage 2. When the marginal product becomes negative, average product becomes declining, and total product is also declining as a declining rate. That's called stage 3rd. So it is very important, and the relationship will. It is very important to understand the relationship between the TP and MP. That means total product and marginal product. A relationship between the average product and marginal product. So let's begin the relationship, which is being derived from the diagrams, from the tabular representation, as well as the graphical representation as well. When MP is increasing, when marginal product is increasing, total product increases at an increasing rate. When MP is decreasing, TP increases at a decreasing rate. When MP is zero, TP is maximum. That means it's a constant as a peak level. When MP is negative, TP is decreasing. So this is a very you can see important relationship to understand. And from the relationship or knowing the relationship between total product and marginal product from the table as well as with the graphical representation, it is very easy to drive the relationship between the total product and marginal product. When we talk about the relationship between the average product and marginal product, when MP is above EP, average product is increasing. When MP is below AP, average product is declining. When marginal product is equal to MP, that means average product is maximum. If you can see, that is a point where both are increasing, but at the point where they intersect each other, that is a maximum point where AP is equal to MP. But when MP is below the AP, there a curve which is below the AP, that means average product is declining. When MP is above the AP, that means AP is increasing. If you see in the diagram, average product is above MP. It means average product is increasing. When marginal product is below average product, that means average product is declining. When they intersect or they equal to each other, that means average product is maximum. So this diagrammatic or tabular representation states as more and more variable inputs will be used, while consider the other variable inputs will constant, the total output increases at a diminishing rate. It's written that stage the result, the outcome of stage third, the total output will increases but at a diminishing rate. And that's stage third. That's a conclusion of the law of variable proportion and the law of diminishing marginal returns. Let's talk about the three main stages, stage one, stage two, and stage three, through the theoretically and what perspective these stages refers to. Stage one, that is the proportion of fixed factors will be included with the variable factors in order to utilize the you can say the fixed factors to get the same or maximum level of output, or in an optimum resources, or will be involved all the level of inputs including fixed and variable inputs. When we talk about stage second, it's called the you can say a law of diminishing returns. Why? Because it refers to an efficient range of production where the combination of all the inputs are fully utilized, because it reaches to the maximum point of total output where the maximum or the peak you can say maximum the peak level of output is fully utilized to achieve its major goals of the production. When we talk about the stage third, it is the proportion of fixed factors which is lower than the variable factor. That means variable factors are used more than the fixed factors in stage third, which also increases the value of the variable factors and the total and ultimately it declines the total output. So if any of the manufacturers or the researcher utilize the maximum to maximum variable factors or variable inputs, it automatically declines the total product, and that's called the overuse or overcrowding of the variable inputs. So in stage one, it is very important to know that fixed factors is equally important while using the variable factors, and ultimately this is the outcome, and this is the outcome of the stage third where the producer would not like to operate at this stage. this stage is not profitable. Stage 1 and stage 2 is very much profitable, but stage 3 is not profitable, as the total output, average output and marginal output, it always both are average and total product is declining and marginal product has become negative, and none of the producers and the manufacturers will never would like to operate at this stage. That is stage third. So this is the children of law variable proportion stages, that is stage 1, stage 2 and stage 3, which is very important to understand periodically, where just after finishing up the tabular or graphical representation, that's the results of the stages, that is stage 1, stage 2, stage third. Then after reaching out, after graphically representation the shapes of the three curves, now what would be the result and outcome of the stage 1, stage 2, stage 3 theoretically. So these are the results on your screen. So the next concept is the long run production function. When we talk about the isoquants analysis, when we talk about the returns to scale, we talk about the long run production function. So when we talk about the law of diminishing marginal returns or the law of variable proportion, we always talk about the short run production function. So when we talk about the long-run production function, the one of the major concept comes under long-run production function, that is the isoquant analysis. What is isoquant? Means equal and quant means quantity, that is the factor inputs. So when a particular manufacturer or the organization or a researcher combines the two level of factoring, both labor and capital, that yields or produces the same level of output, this is which is also called the total product, that's called isoquant. Isoquants refers to all those possible combination of two inputs, namely labor and capital, that produces the same level of output, that is total output. It's called isoquant. In other words, the such term is also called the isoproduct curves. So in the same, in other words, it's generates. So if anyone combine the two level of factor inputs, labor and capital, which produces same level of output or any other outputs except labor and capital, any other outputs which produces the same level of output, that's called isoquants or isoproduct curves. So when we talk about isoquants, here the isoquant schedule is also being maintained, which shows a combination of capital and labor. So which has been shown over here, the production of two variable inputs. The capital has been shown 1 to 5, and the labor units, that is 1, 2, 3, 4, 5. And every labor have a subcategories of units, that is 250, 450, 600, 700, 800. It means in the first unit of labor, uh, in the first category of labor, the units are almost increasing as an increasing rate. But when we reach to the second type of labor, or third type of labor, or fourth type of labor, or fifth type of labor, it also increases at an increasing rate only. So it means there are various combination of capital and labor. So using two capital, or you can say two units of capital or 2 units of labor, the total outputs would be 850 units. If you check out over here, that means that any of the combination of labor that yield same level of output, it would be 1200, it would be 950, it would be 800. So that's called the isoquants. When we talk about isoquants, which always states when you combine two level of factored inputs, labor and capital, it yields same level of output. So if we talk about 800, or if we combine labor and capital, 800 or 850 will get the same level of output, labor and capital. That's called isoquants. So if we talk about 650 or 850, that's called isoquant. So if we combine labor and capital, check it, 450, 600, 700, 800. When we talk about the second category of labor, that is the output is 450, 650, 800, 900, 950. So when we talk about five third cat units of labor, the output is 550, 800, 950, 1050, 1100. So it means by this isoquant schedule, that any combined which yield the same level of output. So if anyone have the same level of output, so that's called isoquant, which shows that by combining the two factor input, the same level of output has been produced. And when we talk about the isoquant schedule, it is a representation which showing two different factor inputs, namely labor and capital, with their respective level of outputs. And that's called isoquant schedule. So if a firm, let's say, if a firm needs 900 units of output, there are few combinations, such as two labor and four capital, or four labor with two capital. So you can use any of the combination if the firm needs 900. For example, if the firm needs 450 level of output, then it can use the second unit of capital, or a first unit of labor, or he can use, when we talk about 450, if any of the 450, he can use that. If any firm needs 1100, so 1100, either the firm can combine third 3 units of labor and 5 units of capital, or another option is 5 units of labor and second and third unit of capital. So this is an options of combination has been given, that is labor and capital. So let's talk about the characteristics of isoquant curve. There are four main characteristics or features of isoquant curves. So isoquant curve can be downward sloping, can be convex to the origin. So first one is isoquant curve slope downward from left to right. If you can see in figure A, that is the curve which is in red color, the isoquant curve is downward sloping from left to right, and that is one of the property. If you say, in other words, if one input has to be compensated by reducing or increasing the another units of another input, factor input. That's the main reason that isoquant curve slopes downwards from left to right. Any researcher or manufacturer have to compensate for one unit to and for one unit of one input to another unit of another input. The compensated ratio will always be arise, and as a result, the isoquant curve will slope downward from left to right. That means there is an inverse relationship between the two factors inputs and their associated units. The next one is isoquant curves are convex to the origin, as you can see in figure A also, that the red mark has been given, and the two other curves, that is in the another color, light green and light blue, it means it convex to the origin. Why it convex to the origin? Uh, because every isoquant has a different level of output, that is first isoquant, that is IQ1, IQ2, or IQ3, and that's the main reason with both different level of output will portrays the higher level of product or higher level of output, and accordingly the manufacturer choose the higher level rather than remains on the lower level of output. So when we talk about the isoquant curve are convex to the origin, in the red line, in the second figure, red line is convex to the origin where the x-axis and y-axis are given, and origin, which is ultimately shows that the isoquant curve has an inverse relationship between the two factors input along with the level of output. So when we talk about the third category or third feature, then an isoquant line to the right represent the larger output. Of course, that's very true if there are three curves or three isoquant curves has been shown, that is in red color, in green color, and in light blue color. So light blue it shows the lowest isoquant. Then we talk about the red, which is the which is the higher isoquant, and the green color, which is the highest isoquant. So if we talk about the isoquant line on the right, if we talk about on the right, it's green, that shows or that represent the larger level of output or a highest level of output. A manufacturer can choose any of the isoquants or leave the lower isoquant to reach the higher isoquant, which that yields the higher level of output, and that's called the isoquant line onto the right, which representing a larger level of output. But when we talk about the figure C, that isoquant curve never intersect each other. That's very true. It never intersect each other. And secondly, it never touches on x-axis and y-axis as well. So in the diagram, it can shows that the red curve and the green curve, if we shows that they cut each other, but they cut each other in that way where which are where the outcome and the result doesn't arise, and as a result it never touches the x-axis and y-axis, neither intersect each other to get the possible outcome. So if they intersect each other, that means no possible combination of factor inputs will be that yield the same level of output, and as a result they never intersect each other. The next concept is isoquant map. Isoquant map, which is shown a three combination of isoquants curve that yield 450 units, 600 units, 800 units, and 1200 units. If we talk about Q1, that is 450 unit, that is the lowest isoquant curve or the lowest quantities that are utilized to yield the 450 output. Q2, which is a higher level of isoquant that yield 800 units level of output, and Q3, which is the highest isoquant, which yield the 1200 unit of output. In a graphical representation, if a researcher shows a three combination of isoquants curves, that's called the isoquant map. Isoquant map refers a graphical representation that shows a different combination which having no perfect substitute that yield the different you can say level of output, showing the higher level of output to Q from Q1 to Q3. That's called the isoquant map. So this is a way to show up isoquant map in a very precise manner, and that curves which shows a downward sloping curve or convex to the origin. If we talk about downward sloping curve, it always you can see from left to right in a very straight line. But when these curves are convex to the origin, it always shows a declining or a constant in a downward slope which is convex to the origin. The next concept is marginal rate of technical substitution. It is a rate, or you can see a technique to estimate the amount of capital input to replaced by a labor input without increasing or decreasing output. That's called marginal rate of technical substitution. It means it refers a rate of sacrificing the one unit to another unit by keeping the level of output constant. That's called marginal rate of technical substitution, where one input is substituted by another input, whereas the capital is substituted by labor. So that's called the marginal rate of technical substitution. And how to calculate the marginal rate of technical substitution? That is the change in capital by change in labor. Mathematically, that is delta K by delta L. So it just a ratio of you can say amount of capital by amount of labor. So if you increase one size of one unit, if you increase one unit of labor, that means you have to, the particular researcher has to decline the another units of capital. So that's called the marginal rate of technical substitution. Now we talk about the returns to scale. When we talk about returns to scale, it's called talk about the law of returns to scale, which is categorized into three parts. The first one is increasing returns to scale, constant returns to scale, and declining or diminishing returns to scale. So when we talk about increasing returns to scale, it refers to all the factors of production which increased in a given proportion, and of course the output will also increase by an increasing rate. I repeat, all the factors of production are increased in the same proportion or percentage. As a result, the output would also get increased by a greater proportion. And as a result, when you see the diagram or the isoquant curves is increases in the arrow is also increasing. That means from 500 to 800 units or 600 to 1100 units. So when we talk about the you can say lower blue line isoquant curve, and it increases to another higher isoquant curve. Why? Because the level of output will be it increased by a greater proportion, and as a result it's called increasing returns to scale. So when we talk about the constant returns to scale, that's very true that all the factors of production are increased in the same proportion, but the output will get increased by the same proportion as well. So if the factors of input will get increased by the same proportion, output will also increase by the same proportion, and that's called the constant returns to scale. If the lower is 100 units isoquant curve, the higher curve is also the 100 units, and that's called the constant returns to scale. So when we talk about decreasing returns to scale, and all the factors of production would increase in the given proportion, but the output will also increase by a smaller or by a small change of proportion. That's called a decreasing returns to scale. It means output would get increased at a decreasing rate. That's called decreasing returns to scale. So if we talk about the lower, it's 15, if we talk about the red line, which is a higher curve and it declines to a blue line, that is, that yields a lower output, that's called the diminishing returns to scale. So when a labor and capital are doubled, that means 1100 units to 200, 100 units to 200 units, the output would get increased from 20 units to 30 units. And why this decreasing returns to scale? Because of diseconomies, where the funds are not available for research and development, where there are plenty of planning, coordination issues occurred within the organization or outside the organization, and that's called the decreasing returns to scale. That's true, the output will get increased from lower to higher isopoints, but very small change, a very small percentage. For example, 20 to 30 units, 15 to 20 units. That's called decreasing returns to scale. Increasing returns could be 100 to 200 to 300 units. So it is increasing. 100 to 100, it's constant returns to scale. So that's it for today regarding the returns to scales or return to law of variable proportion. In the coming session, I come up to a most valuable topics for the relate to this particular block too. So for till time, that's it for today. Thank you so much and namaste to all. It's done. एक सेकंड में बहुत ज्यादा है हमारी